Hi, hello, namaste, my dear all AEE aspirants. Now I would like to provide the key for the questions of control system subjects which were asked in 2024 KPCL AEE. Very simple questions were asked. Let us see those questions and let's make a discussion of those solutions. So, my dear friends, see the question number 1. Which of the following statement is true? So, all the statements are given regarding root locus. See, if you are very good at the construction rules of root locus, you can easily answer this question. See here, you just consider the statement number 1, the root locus is symmetrical about real and imaginary axis. No, my dear friends, the root locus is always, so let me write here, the root locus, in short form writing it, the root locus is always symmetrical about real axis only. The root locus will never be symmetric about imaginary axis. Root locus is always symmetrical about real axis only. Always symmetric about real axis. Symmetric about the real axis. Right? Okay, but here since he has mentioned that the root locus is symmetrical about real and imaginary axis, this statement is wrong. Anyhow, we need to pick it out. We need to pick out the right statement, right? The root locus. Statement B, the root locus starts at zeros and terminates at poles. Zeros. This is one zeros here. My dear friends, always root locus starts from open loop poles and terminates at open loop zeros. Again, this statement is also wrong here. I am writing here. What is the right statement? Means here the root locus always starts. The root locus starts from open loop poles and terminate at open loop zeros. But he has given reverse idea. The root locus starts at zeros and terminates at open loops. Wrong statement. If you see the statement D, the number of root locus approaching to infinity is equal to number of poles. My dear friends, here, how many number of root locus branches will terminate? Actually, here, number of root locus branches start from open loop poles is equal to P. But then number of root locus branches terminate at open loop zeros is equal to Z. P nothing but number of poles, Z nothing but number of zeros. Next, number of root locus branches terminate at infinite is equal to P minus Z. So how many number of root locus branches terminate at infinite means here, my friends, it is P minus Z, not P here. He has given P here. Then if we see the statement C here, the breakaway point must lie on the root locus. Yes, of course, my friends. Similarly, what are the breakpoints? Breakpoints means here, breakpoints are those points at which root locus branch will arrive the real axis or will leave the real axis. The points, breakaway point, the point where root locus branch leaves the real axis is known as breakaway point. Breaking point, the point where the root locus branch arrives the, my friends, for example here, if I conjure here, so if I conjure, so if there is a pole, there is a pole here. So here, first of all, root locus branch start from this pole and they arrive, they approach a breakaway point and they leave then. They leave the real axis then. So this is the breakaway point. So breakaway point or break-in point, break point must exist on root locus. Must and should exist the root locus. Break points always lie on root locus here. So the break point must lie on root locus. This is correct here. Option C is the right answer. Option C is the right answer, my friends. Whatever the statements provided in the options A, B and D are wrong statements. So as I told you very clearly, if you are good enough in construction rules of root locus diagram, then you can easily answer this question. Right? Let's see the next question here. The Bode plate of a system G of s into H of s equal to k by s square intersect 0 decimal line at omega is equal to 2 radian per second. My dear friends, here G of given transfer function G of s into H of s is equal to k by s square. I would like to find G of j omega into put s is equal to j omega. G of j omega into H of j omega equal to k by j omega square. J omega square. My dear friends, here modulus of magnitude m is equal to modulus of g of j omega, means I am going to find out the magnitude of the given transfer function. Modulus of g of j omega into h of j omega equal to, so magnitude of this whole thing k by j omega whole square, means it is simply k by omega square, k by omega square. My friends, already he has given that, see, but he has given the magnitude in terms of decibels. So magnitude in decibels, to find magnitude decibel, we need to find here, we need to apply 20 log m is equal to 20 log, what is m, my friends, here m is equal to k by omega square, but already mentioned the magnitude here, it is 0 decibel line. So my friends, then what happened here, log k by omega square, actually here this is log base 10 here, is equal to 0. Then what about k by omega square is equal to 10 power 0, it is 1, but k by omega is already provided, omega is given as 2 radians per second, so k by 2 square is equal to 10 power 0, means here 1, so k is equal to 2 square, which is not much, k is equal to 4 here, k is equal to 4, where it is here, it is given in option A here, option A is 4, right? So let's see the next question, my friends. In force voltage analogy, mass of the mechanical system is analogous to. So for example, my friends, if I consider mechanical translational system, what is the equation? Mechanical translation system, the equation is, my friends, the equation is F is equal to m d square x by dt square plus k dx by dt plus, sorry, b dx by dt plus, b means here damping coefficient, b dx by dt plus kx. You know here m stands for mass and b stands for damping coefficient, damping or friction coefficient or friction constant, and k is spring constant. Right. Then what about, my dear friends, in force voltage analogy, in RL series circuit, what about the in electrical system? In electrical, that is in RLC series circuit, what is the equation, my friends? So I am going to get force voltage analogy. Then what about the equation here, my friends? The equation is V is equal to my friends, I into dq by dt, right here. Actually, if we consider a series RLC circuit, RL circuits, if you apply KVL, what is the here? VR plus VL plus VC, right? So V is equal to VR plus VL plus VC, right? VR plus VC, my friends. So here V is equal to, final equation is L. If you apply KVL here, you will get L d square q by dt square plus R dq by dt, plus q by C. If you compare, what happens? Mass is analogous to inductance. Here mass of the mechanical system is analogous to inductance. So here he didn't ask. Friction coefficient is analogous to damping. Right here, displacement is analogous to here charge. Spring constant is analogous to 1 by C. Here, my friends, if you compare here, mass is analogous to inductance and displacement is analogous to charge and friction is analogous to resistance and spring constant is analogous to 1 by C. Anyway, he just asked about mass. Mass of the mechanical system is analogous to inductance. Option A is the right answer. My friend, the largest error between reference input as well as the output during the transient period is called, see my friends here, So if we consider a response, the second order response, so consider this is a steady state value or this is a reference input or steady state value. So my dear friends, see the second order response here is like this right here. So maximum, see here, it is reference input, and this is what is maximum output, right? The reference input and output during transient period. This is transient period this is nothing but MP, nothing but maximum peak overshoot or peak overshoot. So the difference between the largest error, this is the largest error between reference input and output. Reference input and output is known as peak overshoot or simply overshoot, peak overshoot. So the largest error between, this is the largest error between reference input as well as the output during transient period is known as maximum peak overshoot. So peak overshoot. Option C is the right answer. The transfer function of the system y of s, u of s, y of s by u of s, right? Y of s by u of s, whose state space equations are given as given below is, my dear friends, he has given x1 dash of t, x2 dash of t is equal to 1, 2, 2, 0 into x1 of t, x2 of t plus 1 by 1, 2 to u of t. But if you compare, what is the state equation in x dash of t equal to a into x of t plus b into u of t. If you compare, what is matrix A here? If you compare, matrix A is equal to 1, 2, 2, 0 and matrix B is equal to 1, 2. Matrix B is equal to 1, 2. Madam, then what about, he has also given y of t is equal to 1, 0, x1 of t, x2 of t. But actually, what is state equation, my friends? Y of t is equal to c into x of t plus d into u of t. So C matrix is called 1, 0 and no D matrix. So here matrix C is 1, 0 and no D matrix, so 0. Matter friends, from state equation, how can we find the transfer function? Directly we have a mathematical expression for it. What is that? See here. See, from state equation, from state model, the transfer function is given by simply C into Si minus A inverse into B plus D. Anyhow, in this question, matrix D is equal to 0. So, we'll use here C into Si minus A inverse into B. First of all, let me find Si. S means yes. Since the matrix, the given matrix A is of order 2, 2 by 2, 2 by 2, I am going to consider a unit matrix of 2 by 2. So, S into I is 1, 0, 0, 1. So that we'll get here S, 0, 0, S. If you multiply. So, S will be multiplied to each and every element of this matrix. Then we will get a Si. Then Si minus A is equal to what here? S, 0, 0, S minus matrix A is. What is matrix A, my dear friends? Matrix A is 1, 2, 2, 0. 1, 2, 2, 0. So subtract the matrices here. S minus 1, 0 minus 2, minus 2, 0 minus 2, minus 2. S minus 0 means it is S. But I need Si minus A inverse. Si minus A inverse. So, my dear friends, you know here, if we have a matrix, 2 by 2 matrix like this, A, B, C, D inverse, then we'll derivate it as what? 1 by AD minus BC, and these two elements will change their positions. It is D and A, and here for these two elements we need to change the sign, minus B and minus C. So similarly here, Si minus A inverse, how can we find this inverse here? Is equal to S minus 1 minus 2 minus 2, yes. Inverse you find here 1 by AD minus BC, S minus 1 into S. S square minus S minus 2 into minus 2, 2. Matter friends here. So these two elements will change their position, will exchange their position, S and S minus 1. For this, we will change the sign here, 2 minus 2 here. So This is what here, 1 by s square minus s minus 2. So s 2 2 s minus 1. Then we need to multiply here. My friends, here transfer function is equal to c into si minus a inverse into b. My friends, here c, what is the matrix here? C is 1 0 1 0 1 0. Then si minus a inverse 1 by s square minus s minus 2. 1 by s square minus s minus 2 into, what is this? S2 2s minus 1. S2 2s minus 1 into B matrix is what? B matrix clearly given as, my dear friends, B matrix is 1 2. B matrix is 1 2. So I'm keeping this here. This one 1 by s square minus s minus 2 outside here is 1 0 and 1 0. And if you multiply these two matrices, what I'll get here? What I'll get here? S into 1, yes. S into 1, yes, plus 2 into 2, 4. But friends, 2 into 1, 2. 2 into 1, 2 plus s minus 1 into s minus 1 into 2 means 2s minus 2. 2 minus 2 gets cancelled, my friends, here. So 1 by s square minus s minus 2 into 1 0. This will be s plus 4 into 2s. So finally here 1 by s square minus s minus 2 into, multiply these two matrices, 1 into s plus 4, s plus 4, 0 into 2 is 0, right? So then what is that here, my friend? S plus 4 by s square minus s minus 2. Is there? Check here whether it is there in the options here. S plus 4 by s minus, s plus 4 by s square minus s minus 4. Of course, it is there. Option G is the right answer. What we got here? Yes. So here, let's see. Minus 4 is there. We will verify this answer, my dear friends, here. See here. 1 by s square, here, s minus 1 into s square. So this is 4, right? Please, this is 4. This is 4 only, right? 4. This 4 only, right? Here, minus 2 into 2, 1. So s square minus s minus 4. Yeah, s plus 4 by s square minus s minus 4. That is the option, is the right answer. Right, let's see the next question. A system is said to be dash if it is possible to transfer the system from initial state to any desired. My depends. A control system is said to be controllable if it is able to. A control system is said to be controllable if it is able to move from present state to any desired state within finite time interval. If a control system is able to move from present state to next state within finite time interval, then it is known as simply controllable. Observability means here, if the a control system is said to be observable, if it is able to reconstruct the previous states from the present output. So here, a control system is said to be controllable if it is able to move from present or initial state to present state to next state or any state, next state in a finite time interval. At the same time, a control system is said to be observable. A control system is said to be observable if it is able to move, so if it is able to reconstruct, previous states from present output. My dear friends, these are the two statements. Now you conclude. A system is said to be dash if it is possible to transfer, means moving the system state from any initial state to any desired state within the finite time interval of time here. It is controllable. So option A is the right answer. Right? Let's see the next question. The diagonalizing matrix is also, my dear friends, the process of diagonalization gives us eigenvalues actually. That's why the diagonalizing matrix is also known as eigenmatrix. What is that? Eigenmatrix. That's it, my dear friends. It's the keep the previous year questions of the subject control systems which were asked in 2024 AEE KPCL paper. So I am requesting you all to go through each and every solution and get a good clarity. And my dear friends, keep practicing and keep going. I wish you good luck and very all the best.